Okay, guys, this is U4A7. I'm going to teach this the way I teach it with degrees. So this is looking at different ratios, and we're going to use the cast law. Don't forget that this is quadrant 1, 2, 3, 4. This is the related angle, little, I don't know what you call this, little helper here. So when we're looking at degrees at theta, 180 minus theta, 180 plus theta, 360 minus theta. This is to get you the related angle in the first quadrant, and then you use your tables to figure out the size of the trig ratio. Sine is based on the cast law. That hasn't changed. And then this here is between, so let me just fix this up here. This is where I have my angle. So from 0 to 90, 90 to 180, 180 to 270, 180 to, sorry, that should be 270 to 360. So that's how you know what's in what. Now, we got to just make sense of this. And a lot of the issues we're going to have now is dealing with radians instead of degrees. So we got to remember, just remember this, that 360 is 2 pi. Okay, and then if that's the case, so 360 is 2 pi. 180 then is half of that, so that's pi. So if you want to figure out what's in what quadrant, well, half of that is pi over 2. So I go from 0 to pi over 2. Okay, a quarter, so 90 was a quarter of 360, pi over 2 is a quarter of 2 pi. So from 0 to pi over 2 is here. From pi over 2 to pi is equal to 180. That's in the second quadrant. Then I go from pi to 270, which is pi plus a half, so that's 3 halves pi. And then the last little bit is going to go from 3 halves pi, I'll just rewrite it like this, to 2 pi. Okay, so that's how we get this. So this is all the way half a pi, all the way to pi, 1.5 pi, and 2 pi. And that'll tell us what quadrant we're in, and then we'll work backwards and figure out our related angles. Now, when we get related angles, sorry, I still am going to do the same here, but what I'm going to do when I convert here, I have to change this to the equivalent in radians. So 360 is 2 pi, 180 is pi. So these are the formulas I'm going to use to help me get the related angles. Okay, so hopefully this makes sense as we move through this. So the first question asked, what is, so this is from 4C, and I'll be going back and forth on this stuff here. The first question said, what is tan minus 5 pi over 12? Oh, the other thing is this. So if we look at the trig tables, let's just get this out here. We have 30 degrees, 45, and 60. These are the main ones. The other ones you can look at later, but these are the main ones. And we have pi over 6, pi over 4, pi over 3. And even if we get to 90, that's pi over 2. Well, let's go back here, and let's take a look at, where am I here? Let's convert all these. So I had, what did I have first? I had pi over 6, and then I had pi over 4, and then I had pi over 3, and then I had pi over 2. Don't forget that's the same as 1/6 pi, okay? So what I want to do now is I want to change all of these. We're going to be adding and subtracting these in a bit. So what the best way to do this is to change these to the lowest, to a common denominator, and the lowest common denominator between all of these is 12. So pi over 6 is 2 pi over 12. Pi over 4 is, so times the bottom by 3 to get to 12, times the top by 3, times the bottom here by 4, sorry, to get to 12. So times the top by 4. So pi over 3 is 4 pi over 12. And this one here is 6 pi over 12. And we're going to use this, you'll see in a second, to figure out our angles, okay? Because we only have tables for this stuff. So if I ask you, for example, what's 5 pi over 12, sine of 5 pi over 12, we got to mess around with this stuff and then use some more information to figure out where we're going. Okay, so the first question says, what is tan of negative 5 pi over 12? So let's go over here and figure out what that's really asking us. So I want negative 5 pi over 12. See if I can remember that between now and then. Tan of negative 5 pi over 12. Well, one thing you can look at here is, I don't like this negative pi, and people teach this different ways, but I like to switch to positive angles right away. So to get the coterminal angle with this, what you normally do, so if I had something like negative 60 degrees, and I said, well, I don't want to deal with negative 60 degrees, what you would add is 360 to it, sorry, and get 300 degrees, and then you deal with that. Okay, so you go tan of 300, okay, because 300 is coterminal to negative 60. Same with this, but 360 is now 2 pi. So what I'm going to do is I'm going to go 5 pi over 12, or 5/12 pi, and I'm going to add to it 2 pi, or 24 pi over 12. Now, not everyone does it this way, but I like to have positive angles to deal with. So now I've just changed this question to this, and this is asking me the exact same thing. I have 19/12 pi, 19/12 pi or 19 pi over 12. That's the exact same as that. So I haven't changed anything. There's no sign difference or whatever. Now I got to figure out from here, I got to figure out what quadrant am I in. So 19 over 12 pi is in the, well, which quadrant is that? Okay, so in 12s, you got to ask yourself, you look at this, in 12s, 2 pi is all the way to 24. Okay, so that gets me here. Pi is, one whole pi would be 12 out of 12. Okay, 24/12 is 2 pi. And then here I would get all the way to, from 12 to 18/12. And from here I would go from 18/12 to 24/12. This goes from 0, 0 obviously to 6/12, okay, and 6/12 to 12/12. So what all I've done here is I've taken these guys, pi over 12, and changed them into, or sorry, pi over 2, and changed each of these into 12s. Okay, so that gets me 12 pi. So what I had there was, what did I have? 19/12. So 19/12 ends me up in this quadrant here. Okay, so I'm in this quadrant, which is quadrant 4. In quadrant 4, sign is negative. So I'm in Q4. So let's go back here. So I'm in Q4. In Q4, tan. Sorry, tan is still negative in Q4. So that's negative. Let's find the related angle in Q1. And then after we find the related angle in Q1, we'll find the value of it, and then we'll change it all to negative. Okay, so give me half a second here. So here, let's figure this out. The related angle in Q1. Sorry, I just had a little brain fart, I guess. So to do that, 3 pi, so I'm in Q4. So to get from here to there, it's 2 pi minus theta will get me back, will find me theta. So that's something else. Sorry. So what was it? 2 pi minus theta is equal to 19 over 12. All right. So then what I do is bring this over here, bring that over there, and I end up with 5. Sorry, that's 24/12. Subtract 19/12, which is 5/12 pi. Now you may have got that immediately, okay? So my related angle is 5/12 pi, but it's going to be negative, okay? I want the negative version of it. And when I get the negative version of it, that'll be the last step I do. So now I want tan of 5/12. Well, I don't know what 5/12 is. It's not on my table, but so the numbers that are on my table are 2/12, 3/12, 4/12, and 6/12. And I figure out, how can I get 5 by adding or subtracting these digits here, okay? And the easiest way to do it is to say I want tan of 2/12 plus tan of 3/12, okay? And that is, in lowest terms, pi over 6, or 1/12, and pi over 4. So now I want this. I use this thing now. So hold on. I use this to figure out that tan A plus B is tan A plus tan B over 1 subtract tan A tan B. So I'll go back here and figure out that it's tan A plus tan B over 1 subtract tan A tan B, and that doesn't look too nice. But then I will go through here and figure out what that is. What's pi over 12, pi 6 tan? So let's fill this in. So back over here again. So now to my table, my trig table. Pi over 6 tan is 1 over root 3. So back here, I have tan, I have 1 over root 3. And then here I had 1 minus 1 over root 3. And then I got to figure out what tan of pi divided by 4 is. So hopefully this is making sense to you. Pi divided by 4, tan is 1. So that takes me back here. So that's plus 1. And this is times 1. And that turns into this, which is then, which is fine. Now, that's not the right answer. That might not be the answer that you have, because what they've done here is they've taken the root. They don't like the root sign in the bottom of a fraction here. So if you don't want to have fractions at all, what you can do is multiply the top and the bottom by root 3 over root 3. Okay, and if you do that, you're going to end up with root 3 over root 3, which is 1, root 3 times 1, which is root 3. This is root 3 right here, and that is minus root 3 over root 3, which is minus 1. Now, I said earlier that that is tan of 5/12 pi, but I wanted the negative of that, so I throw a negative in front of the whole thing. And that is the answer that they've given you right here. Okay, so that's this guy right here. Now there are different versions. You got to be careful here because this answer is the same as this answer, which is the same as other answers. Now, if you want to know if your answer is correct, what you could do is find out what this is as a decimal and see if it's the same as the answer that you got yourself. Okay, so that is the first question. Let me just get you going on the second question. The second question asks this. No, not that. It asks, where's the second question? Sorry, the second question was, what is the sine of 11 pi over 12? So 11 pi over 12. So the sine of 11 pi over 12. So sine of 11 pi over 12. Well, let's figure out what's going on here. Where is that? Okay, so 11 over 12 pi is just less than 1 pi. So I'm going to end up in this quadrant here. So that's quadrant 2. Okay, quadrant 2 from Cast law tells you that your final answer is positive. So I need the positive answer of this, and then to get the related angle, it's pi minus theta is equal to 11 pi over 12. So then I go pi subtract 11 pi over 12 gets me theta. Okay, and that just tells me that I'm looking for, so pi, so that's 1 pi or 12 twelfths pi. Subtract 11 twelfths pi. Theta is then going to be equal to 1 pi over 12. So I want 1 pi over 12. Let's go back. So again, I don't have 1 pi, but I do have 1 12th pi, sorry, but I do have 2 twelfths. I do have 3 twelfths. I do have 4 twelfths, and I have 6 twelfths. And the easiest way to get 1 12th is to take 3 twelfths and subtract 2 twelfths, which is, that's pi over 4 subtract pi over 6. Okay, so that was that's that one there. Okay, so 2 twelfths is pi over 6. And then what happens with this? This is a sign question, so I want this. And then let's go over to this table that I have here. When I'm subtracting, it's sine A cos B subtract sine B cos A. So let's go back and see if I can remember that. So that's sine of the first one times cos of the second one, subtract sine of the second one times cos of the first one. So let's figure out what that is. So I know this is a bit messier, but sine pi 4, sine pi over 4, and then cos pi over 6. So let me do the pi over 4s first. So back over to my table, back and forth, back to this table here. My pi over 4s, sine is 1 over root 2, cos is 1 over root 2. So back here, pi over 4, that's 1 over root 2, and that cos was 1 over root 2. And now my pi over 6s, I'm going to get my pi over 6s, and my sine is a half, and my cos is root 3 over 2. So that is, cos is root 3 over 2, and this is subtract 1/2. So I have that. Let me just get rid of this stuff here and see if I can clean this up. When I multiply, I'm going to have 1 times root 3 is root 3, and 2 times root 2 is 2 root 2. Here I have 1 on top, 2 root 2, and then I have fractions with the same denominators. I can add them together. 2 root 2 is my common denominator. Root 3 subtract 1 is my numerator. Okay, so that's the answer to question number, what was that? C. Okay, so those are the questions I was asked for. In D, let's look at D for a second. I'm not going to answer it because I'm a little short on time here. D, I want 2/3 pi. Okay, so don't answer that question. I stick with my 12ths. Okay, that's how I like to do it. 2/3 is going to, let's convert that to 12ths. That's 8/12 pi. Okay, so I want 8/12 pi, and then ask yourself, 8/12 pi. If I'm 8/12 pi, what quadrant am I in? Okay, it's bigger. That's bigger than a half, less than 1. So I'm in Q2 still. And then get yourself back over there, figure out what your related angle is in the first quadrant, and then work from there. Okay. Okay, and I am out of time. Okay, this video will stop in a few seconds, so I might as well call it quits.